Hey, yo, spaced out viewers, we be back here at the Smash News Network, least busted name in news, with some more daily space weather content for you. Congratulations on realizing our channel exists. Here's the sun in 131 and 94 angstroms from the SDO, the Solar Dynamics Observatory. 0 sunspots, some significant coronal holes, you can even see them in these wavelengths. A South Pole one down here and a North Pole one up here. We've also got some coronal mass ejections and some sudden geomagnetic pulses to talk about. First, let's take a look at the viewpoint from stereo A, which is the left pane over here, and there you can see a coronal mass ejection. Now, for you new viewers, the Earth is off in this direction. From the perspective of stereo A, once again, stereo A located out here at the gravitational equilibrium point, Lagrange point 5, which puts Earth off to your right from the perspective of stereo A viewing the sun. And the right pane is the Soho-Lascaux C3, located here at Lagrangian point 1. And you can see that coronal mass ejection will miss the Earth. We're keeping our coronal mass ejection warning in place here, as we're expecting one on the earthly side of the sun, someplace around this area. It looks like some activity may be kicking off already. So we'll be keeping an eye on that throughout the day. And when I say eye on, well, the pun is intentional. Yeah, charged particles, folks. Charged particles. You can't just say the word plasma and assume that it's magical. Anyway, here is the sun in colorized magnetogram. Again, 0 sunspots. No areas of sufficient magnetic organization to show us down to the photosphere, the dark umbra associated with sunspots. So here's a great viewpoint. This is 335 and 211 angstroms, and you can see the depth of those coronal holes, especially the southern one. Great view of that. And the 10.7 centimeter radial flux has dropped down below 80, folks. It's all the way down to, I think, 78, 79, something like that. This black line puts it in context for the past year. That's the radial flux. The 10.7 centimeter radial flux is the black line here. That information is at solon.info. Yeah, 78 is the current state. And we've actually pushed the boundary to geomagnetic unrest here just because of a shift in the total field and the BZ. So we're at a total field of 9 nanotesla with a BZ of negative 7 nanotesla, indicating strong South Pole oriented magnetism. There is some geomagnetic unrest forecasted here for late in the day tomorrow on October 18th and early in the day on October 19th. That is from the North Pole oriented coronal hole high-speed stream that's on the way to Earth. Let's take a brief look at global seismicity. It's at moderate levels. We've seen some quakes around places like southern Alaska, the South Sandwich Islands, and so on. No major quakes, nothing over a 6 magnitude, I think. And I'm just going to let the list scroll here, citing anything that I feel like citing. By the way, that one there in the Cayman Islands is a 5.3 magnitude, one of the larger of the past 24 hours. The North Atlantic saw one here. That's a bit of an odd spot there, east of the Caribbean. The Benin Islands saw a 526-kilometer deep 4.8 magnitude quake. And the Kermadec Islands saw a 5.1. Also, Japan saw a 5.1. At almost the exact same time as the Kermadec Islands quake there, those quakes only about 2 minutes apart. Both 5.1s, both near the surface. Otherwise, just moderate levels here. A deep quake in Argentina. And quite a few quakes around Alaska. Leave us a comment if you felt any of those earthquakes. Next, looking at volcanoes over the past 24 hours. La Palma continuing to explode and produce large plumes of volcanic ash and gas over the Canary Islands. Current ash plume altitude, flight level 100. It's a 10,000-foot ash plume. Please don't fly your John Denver-style ultralight aircraft over the caldera. Suwanosejima also erupting, flight level 085. It's an 8,500 foot plume of ash from Suwanosejima. Mount Tall now on the list, producing 23,000 tons of sulfur dioxide per day. So strong fumarolic activity continues there as it's outgassing big time. Also causing some VOG. Don't breathe VOG, folks. It's bad for your health. It's also producing a nearly 10,000 foot plume of volcanic ash, Mount Tall in the Philippines. Fuego, 15,000 foot ash plume over Guatemala as it explodes. Sangay, 19,000 foot ash plume over Ecuador as it explodes. Revenador, 14,000 foot ash plume over that same country of Ecuador. Revenador exploding. Sabancaya, intermittent emissions of volcanic ash, fertilizing Peru. And Nevados de Chilean is producing a flight level 140. It's a 14,000 foot plume of volcanic ash. Please don't pull out the caldera. Please do visit our links and attempt to support the channel financially, as YouTube is less than favorable to our content. So please do not pull Volta Caldera. It could be unhealthful. We need the views on YouTube. We need you to visit the links in the description. So click them. Below the video, you'll find all kinds of links, such as to our Redbubble shop, the 12 other designs visible there. We do have some designs that aren't publicly visible, but those are the ones that are. Anyway, welcome to the Neo Renaissance. You can find links to that on our homepage, smashomash.com. That link is the smAsho merch link. And the print quality is spectacular. Let's take a look at magnetic quality. We've seen a recent divergence here in the GOES 16 and GOES 17. That's the last 3 days of magnetometer measurements by those two satellites, geosynchronous satellites, yes. Next, looking at the current sheet. Yeah, the heliospheric current sheet. And this is one of the most important pieces of data we can look at for things like solar forecasting, folks. It's the Gong 2 data, part of the National Sunspot Observatory. Earth is solidly in a South Pole current sheet. There it is in red. North Pole current sheet shown there in green. Here's the line-of-sight view of the same data from 51 ground-based magnetometers and magnetometers on stereo A and stereo B. Again, strong South Pole current sheet at the moment. And here's the line-of-sight coronal hole plot showing you the sun's B field in blue. That's the field that goes through the magnet, this magnet being the sun. And you can see the well-defined South Pole coronal holes there shown in red in the southern hemisphere of El Sol, Helios, the closest star, the local yellow dwarf, whatever you'd like to call the sun. Here's a visualization of that in 193 angstroms, a great SDO wavelength to show coronal holes, and you can see the well-defined south and north coronal holes there, both in the Earth-facing zone. We can expect some coronal hole high-speed wind streams here late in the day Monday, early in the day Tuesday. Again, no sunspots. Coronal mass ejection warning remains in effect. Solar flare warning has subsided as sunspot 2882 has set. It still does have the capacity to produce a significant flare, I think, but that is waning quickly as it gets too far away from Earth to produce a detectable large flare. Here's the last 3 days of the GOES X-ray flux, and there was a tiny C-class flare there. Otherwise, calm conditions in terms of the X-ray profile of the closest star. No proton strikes, no relativistic particles striking the geospace. How about the real-time solar wind? We'll show you how we pushed geomagnetic unrest conditions. This sudden shift in the BTBZ right here. It's all about that. When we see a strong negative BZ component, which is this red line here, that is more geo-effective. And just that shift, without even changes in the total field there, which is the white line, the BT, just that shift in the orientation of the field to the South Pole was sufficient to produce some ground magnetic perturbations and so on. We'll show you that in a minute. Current solar wind conditions are about 5 protons per cubic centimeter for the solar wind density. Solar wind speed, 351 kilometers per second, basically background levels. So there's the KP index, and you can expect to see this come up a bit here in the next couple of hours. The next update of this should show a KP 2 or 3, and I can tell because of looking at the Geospace Magnetosphere movies. So here is the Magnetohydrodynamic pressure over the past 4 hours, and you're going to see an uptick here in the pressure, I believe. I'm actually seeing this for the first time myself, so you should see a small uptick happening here in the pressure in the past 2 hours. And that's just pure magnetism there, folks. That's not because of solar wind density or speed. So here are ground magnetic perturbations. And you'll see some significant ground magnetic perturbations here as well. And that is all about the magnetism. Just the shift in the BZ alone produced this, not any sort of an uptick in the solar wind density or velocity. You can see some pulses coming out of the Indian Ocean. Some significant geomagnetic pulses there. Changes to Earth's B field, geospace delta B. Again, it's 4 hours of data. If you're wondering where stuff is, Mars is looking pretty lonely here on the opposite side of the sun. Let's advance this 1 week. There's where things will be in a week. Full moon coming on the 20th. That's where things will be on the 24th. Here's a star chart. Mine faces the south, as I'm facing the south, and so does my sofa. We've got Mercury rising, as well as Mars. So Mercury and Mars here rising ahead of the sun. If you've got a low horizon, you might be able to see those two planets. And we're located in Lehigh Valley, Pennsylvania, if you're wondering. Let's do a brief cosmology segment. First, AccuWeather's Above the Clouds story. It's International Observe the Moon Night on yesterday. Anyway, there's a full moon coming on the 20th. And if you don't believe the moon landing occurred, I'm really not interested in your silly comments. Let's talk about a variable star, V826 Cassiopeia. It's our, quote, random and, quote, object of the day. Entry number 12 at the Neil Gehrels Swift-Bat X-ray Observatory is V826 Cassiopeia. It's a very hot star. It's bright in mainly the infrared spectrum, but it also has an X-ray signature and more. Let's take a look at it. There it is, an infrared light from the 2MASS. It's V826 Cassiopeia. Let's take a look at some other wavelengths as well here. If you look at the photometric data on this one, you will see that it is quite bright in especially the infrared spectrum, less so in radio. And you can see those points fall off in the X-ray, gamma ray spectrum as well. Let's take a look at some other wavelengths here now that we've looked at the 2MASS, which is infrared. Let's look at Pan-STARRS optical. Pan-STARRS is a great high-resolution survey there for you. There's the variable star. How about an ultraviolet? And it has basically no ultraviolet signature at all. We'll see if it shows up in any false color X-ray images. Let's see if we can find it in X-ray real quick. Anyway, that was pretty unfruitful. Here is an X-ray image of the area. Let's bring it back to the 2MASS again here to show you a great thermal image of V826 Cassiopeia. Today's, quote, random and, quote, object. Let's talk about the Einstein Cross. This galaxy here, it looks like it's got a quadruple nucleus, but actually that's lensing of a background object apparently. And we also see variations in the brightness of that based on stars passing in front of the core of that galaxy. The Einstein Cross, one of the lensed image phenomenon that we see. That's the apod.nasa.gov, the astronomy picture of the day. That's today's cosmology segment. Check our other playlists. YouTube.com/smashamash/playlists for over 200 cosmology segments. Let's check charging hazards. We don't see any charging hazards. Here's the one-year chart of the electron flux as reported by Solon.info. And here's the 3-day chart of the electron flux as measured by the GOES 16 and 17 using radiography from their geosynchronous orbits. These are measured at the F ionosphere layer. We're going to show you that in a minute as well. Here's the electron forecast. No arguments there. The green boxes are the forecast. The yellow diamonds are the observation. We're going to show you the total electron content forecast next. The electron content between your GPS satellite and your handset. The locations on planet Earth where GPS errors are most likely to occur are where you see the reddest blobs, as communicating through dense blobs of electrons is problematic. Next, a diagram of the atmosphere showing you where the F ionosphere layer is. It's at about 300 kilometers of altitude. Here's your ionogram animation, courtesy Australian Government Bureau of Meteorology. We hope Australia fixes its insanity soon. We hope Australia comes out of its covidiotic frenzy and is cured of covidiocy. We're pulling for you, Australia. And we wish you all the best. Anyway, we see some high-frequency anomalies here, certainly. And let's look at the anomalygram after we look at the latest image, which is 11:15 Universal Time. Pardon the lateness on our video today. And we're also seeing low-frequency anomalies. This animation is anomaly in megahertz from the 30-day median. And you can see low-frequency anomalies here, mainly north of the equator, what you would expect, as it is now autumn in the northern hemisphere. Are you enjoying fall so far? Or if you're in the southern hemisphere, are you enjoying spring so far? Let us know in the comments. And don't forget to visit the links in our description as well. Support the channel, become a member of the SMASH team, perhaps. There's the latest image in the anomaly map. And you can see high and low frequency anomalies showing up there at 11:15 Universal. All right, let's continue on with bonus features, starting in the form of the El Teide ground-based solar observatory in El Teide, Spain. Yeah, it's in the Canary Islands. And there doesn't appear to be any volcanic ash covering up the imagery here. It's the hydrogen alpha imagery in 6,562.8 angstroms. Some filaments, coronal mass ejection warning remains in effect. How about the latest intensity gram? There you go, to show you 0 sunspots. How about the latest colorized magnetogram to show you any areas of magnetic organization? Not so organized at the moment. We'll close out with 3 more full disk views here of the closest star. This is 304 angstroms ionized helium, one of my favorites. It shows filaments very well, and you can actually see some filament activity right up here. I'll let it play through one more time. And here's a composite. This is 304 and 171 angstroms ionized helium and iron. Probably my favorite composite. Great at showing magnetic features as well as filaments. And here's my favorite wavelength overall. I think 171 angstroms. The golden hues of 171 angstroms. Keep in mind, folks, these are all false color. This is all ultraviolet light, not visible to the naked eye. This imagery is colorized for convenience. And it also looks cool. Anyway, once again, congratulations on realizing our channel exists, and may that solar wind be at your back.